Hello, this is Britt LaRoche. I'm a senior solutions architect at MongoDB. And today I'd like to talk about the exciting world of machine learning with MongoDB Atlas, Realm, and TensorFlow.js. And some of the changes that have happened to machine learning over the past year or so a couple of years, is very fascinating. We're able to actually do machine learning in the cloud as a service with Google using TensorFlow. We're also able to use database as a service with MongoDB Atlas. So we're able to run both database as a service, machine learning as a service, and accomplish some amazing things. Gone are the days where we had to install complex Hadoop infrastructure in Spark just to do machine learning. So today we're actually going to take a look at a fictitious company called Brave Organics, and they've acquired a couple of gas stations, and they believe that if they can find the way to maximize the price and profit, that they can become profitable and successful in their gas stations that they've just purchased. So we'll take a look at some of the data that they've loaded in for the past 90 days in fuel sales and load that data from the database and prepare a model. And so what we're looking at here is the data for store 101. I'm going to go ahead and actually do some machine learning against that. So I'm going to train the model against the data that we have. And right here, what we're seeing is the loss function being calculated, the number of layers, the number of neurons, and this function is actually going off and to the races. What we're seeing is TF-Viz. This is TensorFlow visualization, and it's running in the browser. This is nothing more than an HTML page with JavaScript. I'm using Realm, which is a serverless compute functionality that's built around MongoDB Atlas. It provides connectivity to the database and allows you to run serverless functions that prepare your data and model to be trained. And then once the data is trained and the model is returned from the machine learning, you can actually store that in MongoDB Atlas and then share it with other people so that they can load that model and they don't have to retrain it. So this is actually running. People often ask, look at the loss function drop as it begins to match the data. People often ask, where is this running? And so we can actually find that out. I'm going to go ahead and do more tools, go into developer tools. And we'll go to the console, and we can actually type in TF, that's for the TensorFlow that we've installed, .version. And as we type in TF version, we can see that we're running version 2.6, and we'd like to know what we are running on the back end. So we'll call the function get backend. You can see WebGL. And what that means is that this is actually running on the graphics card on my computer. WebGL means that it's using the browser's graphics layer, which means that it's using my computer's GPU. And so we've actually finished. We have now trained the model, and I can actually go over here and save that model. When I do so, it saves that model to MongoDB Atlas, and it can be used by other people. So let's take a look at store 102 data. We'll actually load this data in and prepare the model. And what we see is something that's very different. It's very price insensitive up to a point, and then people simply stop buying. So now I'm curious about store 101 and store 102's location. So I'm going over here. This is also a Realm application. I'm able to actually use the Leaflet API to do map and coordinate data. We have geospatial queries in MongoDB, and I'm able to actually go ahead and see store 101 is here, and it's charging $1.99, and it's actually in a neighborhood. So let's take a look at store 102. So go down to store 102, we'll take a look at that. They're right on the freeway. They're actually on the Dallas North Tollway, and it makes me think that that's probably why people pass by if the price is too high, but they stop up to a certain point, no matter what the price is. They need the gas and they're on their way to work or moving. So let's take a look back at our data here. Instead of actually having to train the model, I'm just going to load it because we actually saved that model from the database. And now I can do some predictions. So I know that they're selling at $1.89. So we can actually put their baseline in here. Now let's raise the price to $2.89. Let's hike it $1 and see what we do. And so what happens is we cut our sales in half. And so we've lost about $6,000 a day. So somewhere between $1.89 and $2.89 is probably where we need to be. So let's do $2.50. And we're actually making about $3,000 more at $2.50. Let's refine that. Let's go down. Let's go down to $2.35. And we're at $613. That's quite good. So what I'm doing is doing predictions. And what we can do is actually do reinforcement learning in the browser as well, so that the predictions are made and the price is given, like the best price by machine learning as well. But for now, we'll play with it as humans to see what the data is. So $2.35 is pretty good. Let's go down to 234. And not as good. Let's go up 236. Slightly better. Let's do 237. Nope. So 236 it is. That is the right amount. So we predict that amount, and we've actually increased our profits by about $4,000 a day by using machine learning. Very well worth the effort. Everything that we've done here is actually in a GitHub, and we've got the link below. If you're interested, please follow. One last thing I'd like to do is show you how you can actually change we're actually storing information on the price. I'm going to go ahead and show you how we can actually do something else. Usually when you do machine learning, they go, that's great. Now we want to take a look at temperature data. So they're actually throwing new things at you. So we'll load this data from the CSV file. And then we'll actually go take a look at store 101, load the data from the database. And you notice that over here, we don't have a new diagram yet, because we're actually going to take a look at high temperature. And when we took a look over here, there was no high temperature in the data. So we're actually do a find, we're actually retrieve that back, and now we have high temperature. So we didn't change a line of code. MongoDB has a flexible data model. We simply imported that data. And now I'm going to go back over here, and I am going to call this temperature versus gallons sold. And then prepare the model, and we have a new chart, and not changed a line of code, but I'm able to actually load that data in. I didn't change anything in the database, and I'm able to train a new model. What that shows me is that I can actually go against any collection or load any data, make any changes that I need, and immediately, without changing a line of code, do machine learning against the data. Very powerful. One last thing I'd like to show is how this all fits together. And this is really all we did was the realm distribution to connect to the database, TensorFlow.js, and TF-Viz to actually do the visualization. There is a GitHub in the link below. Please stop by, take a look. Within 60 minutes, you'll be able to create your first TensorFlow application and reproduce what we've done here. Thanks for your time, and I hope you have a good day.